Good afternoon. This is Patrick here, and today I will be doing the interactive advanced concept presentation number 4 for Chem 2. This is the elephant toothpaste experiment. So pretty much with this experiment, we're going to be creating elephant toothpaste. It's a real classic example of an exothermic reaction. This reaction does create oxygen and water, and it does make quite a mess too. So we are going to be using a few basic tools for this experiment. So first, I do have myself some hydrogen peroxide here. I'm not sure if this will be strong enough. This is 3% peroxide, and there was recommendations in the lab to use 10%, but I couldn't find any 10% by where I live. So we're going to see how the reaction does with 3%. I also have myself some dry instant yeast here. I'll be using a packet of this, and I'll be mixing that dry instant yeast with this glass, or some of this warm water here in this glass. I also have myself some red food coloring, some food dye here, and I also have some dish soap. So let's get started with the experiment. So for the first part of my experiment, I am going to put a little bit of this 3% hydrogen peroxide in this glass here. Wish I had a different glass for this, but hey, what are you gonna do? Alright, so I have my hydrogen peroxide in this glass. I'm now going to top this off with a few drops of the dish soap here. Alright, awesome. My hydrogen peroxide and dish soap to the side. Now I have myself just a cup here, and I'm going to be adding the instant yeast to this cup. I'm just going to fill that up. One packet. Oh. Awesome. Alright, so we do have that instant yeast now inside of this cup. So we're just going to top this off with a little bit of this warmish hot water. Not too much, so it's I don't want it to be too much. Oops, just fill a little bit. Okay, and I'm just going to mix this with the spoon now. Kind of hard to see. I couldn't find any more clear glasses. But I'm just mixing up this warm water and yeast solution. Almost forgot one of the most interesting steps. I am going to add a few drops of the red food coloring because we have to make the toothpaste look interesting. So we're going to add some of this food coloring for a nice effect. We've got some new bottle. Alright, we'll add a few drops of this food coloring to the hydrogen peroxide and dish soap. Okay, that's about 5 or 6 drops in there. Ooh, very nice. Now that I have my food coloring, hydrogen peroxide, and dish soap, I do have my mixture of warm water and yeast. So we're going to add this to the glass here and see what happens. Let's see. Oh. I mean, it wasn't as extravagant. Not as extravagant as the YouTube video I saw prior to this. But it does look interesting. We definitely got the gist of what happened here. Ooh, it's really thick. So yeah, I'm going to guess that the reaction wasn't as as strong per se as it was in the YouTube video attached to the lab. I'm going to say it's probably because of the concentration of hydrogen peroxide that I had ready for the experiment. Like I said before, um, the experiment did call for 10% of hydrogen peroxide, and I only had 3%. So pretty much with hydrogen peroxide, it's really recommended to have that 10% just because the higher concentration means that more of an exothermic reaction will occur. So this is probably why my reaction wasn't all that. This looks like a strawberry milkshake. Um, but pretty much what happened here, I'll explain in just a second. So to pretty much explain exactly what happened. So when hydrogen peroxide breaks down, it turns into oxygen or O2 gas and water. So normally this breakdown happens very slowly, but you can make the reaction happen faster by adding, a catalyst. So in this case, yeast is a catalyst in this reaction. Um, it's it does contain a special chemical called catalase, and it helps pretty much break down hydrogen peroxide faster. So this means that if you mix yeast with the hydrogen peroxide will quickly break down into water and oxygen gas, and the oxygen gas forms bubbles. So these bubbles would usually escape from the liquid and pop quickly, but by adding a little bit of that dish soap that we did, it provides additional surface tension, which allows the bubbles to get trapped and creating a lot of foam, as we see here with this foamy pinkish mixture we have. So yeah, this foam looks like supposed to look like a giant squeeze of toothpaste, built big enough for an elephant, I guess. So that is the interactive advanced concept presentation number 4.